In this video, we will look at the language of algebra, the terminology and the vocabulary that is important to form the foundation of doing algebra, understanding the words and things that are happening in the lessons. Our first term is an integer. Integer is a positive or a negative whole number. Some examples of integers are 3, -5, 0, -37. They are whole numbers. Note that an integer is not a decimal. It's not a fraction. It's just a positive or a negative whole number. The second term is a rational number. Rational numbers are the set of real integers and fractions. So before, when I told you we had integers, those were not decimals, not fractions. Now when you incorporate fractions, the word becomes rational numbers. Rational comes from the word ratio because a rational number can always be written as a ratio or a quotient of two integers. Some examples are 1/2, 0.57, which can be written as 57 over 100, and integer 3, but that's also a rational number because it can be written as 3 over 1. The next term is irrational number. An irrational number is a number in the set of real numbers that cannot be expressed as a quotient or as a fraction. It's a non-repeating, a non-terminating decimal number. A very famous example of an irrational number is pi, which is the Greek symbol you see here on the screen. 3.141592. It continues on and on forever, never repeating, never stopping. That is an irrational number. It never stops, never repeats. Isn't that irrational? That's a good way to remember irrational versus rational numbers. The next term is real numbers. Real numbers are rational numbers and irrational numbers. Both of those sets of numbers together. It's any number that describes real world quantities. It can be an integer, it can be a fraction, it can be a decimal. All of these fall in the category of real numbers. The next term is a variable. Variables are letters that represent unknowns. These letters are actually numbers in disguise. We call them variables because the numbers that they represent can vary. Here are some examples. The x in 3x is the x is the variable, and the y is the variable in 7y. Next term is a constant. Constant is a term that contains only numbers. The terms without any variables next to them. We call them constants because their value never changes. A 3 is a 3 is a 3. No matter what happens to it, it's still a 3. In the expression 7x squared plus 3xy plus 8, the constant term is 8. It's the only one that doesn't have a variable next to it. It is called a constant. The next term is an expression. An expression is one or more algebraic terms in a phrase. It can include variables, constants, and operating symbols such as a plus sign or a minus sign. Expressions do not include an equal sign. That's called something else. It's just an expression, no equal sign. Example, 3x squared plus 2y plus 7xy plus 5. This is an expression because it does not include an equal sign. If there were an equal sign, it would be called an equation. Yes, you're right. I know somebody guessed it out there. The next term is terms. Terms are the elements separated by the plus or a minus sign in an expression or an equation. They can consist of variables and coefficients or constants. The example we just used had 4 terms. It had 3x squared, it had 2y, 7xy, and 5. All 4 of those are terms in that expression that we just talked about. Our next term is coefficient. Coefficients are the number part of the terms with the variables. So in 3x squared plus 2y plus 7xy plus 5, The coefficient of the first term, this is the first term, the coefficient of the first term is 3. The coefficient of the second term here is the 2. The coefficient of the third term is 7. And 5, when it's by itself, is called a constant. If a term consists of only variables, then its coefficient is a 1. So if you had just x or just xy, if there is no number in front of the variable, then that coefficient is a 1. Even if you don't see it, you will never see 1xy or 1y. That's not the way it's written in algebra. But even if it's not there, just know the coefficient of a variable with no number is the invisible 1. Okay, those were our terms, our terminology. So let's look at some examples, answer some questions to see if you remember the difference between rational numbers and irrational numbers. So remember, I'll give you a little refresher that rational numbers can be written as integers or fractions or decimals. And irrational numbers do not stop. They do not repeat. They just continue on irrationally. Let's look at these 4. Well, number 1 is 45. 45. Do we think that's rational or irrational? I would say that it's rational because it is a whole number. That's rational. 0.37 is a decimal. Decimals fall in the category of rational numbers also. So I will call this one rational as well. Hopefully you guessed that too. Pi, I told you that pi was a very famous irrational number because it goes on and on irrationally. There's been competitions about the number of digits of pi someone can memorize. And for number 4, 22 over 45 is a fraction, and a fraction falls under the category of rational numbers. Alrighty. Hopefully you got all of those correct along with me. In the next section, we will talk about some properties of algebra or the properties of algebra. So I'll see you in the next video. If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemaths.com where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathshelp.com. We look forward to seeing you there.